Okay, so this is the lesson that you are going to be missing in class today. This is a super important lesson, somewhat difficult to understand, but hopefully we can get it through this video. If you have questions, make sure that you ask. You can either ask myself or you can ask a classmate. So in your table of contents, go ahead and fill out scaling an area, and then turn to notebook page 15 and write today's goal in. Today's goal is that you can describe how the area of a scaled copy is related to the area of the original figure and the scale factor that was used. If you need to pause the video so that you can have time to write that down, that is fine. And as soon as you have that written down, go ahead and play on the video. So today we're going to be building scaled shapes and investigate their areas. And we're going to do this through an activity called scaling a pattern block. And so today, the kids in class are going to actually use physical manipulatives called pattern blocks to build scaled copies. And they're going to work together with partners. But for the ease of use on this video, I'm going to jump over to the online version and show you how this works on the online version. So this goes along with your note sheet. So on your note sheet on the front side, you should see shapes A, B, and C. So you see a rhombus, you see a triangle, and you see a trapezoid. We're going to start with the rhombus, the blue rhombus, and we're going to figure out how many blue rhombuses it would take where each side is twice as long. So I'm going to use this little applet down here, and I'm going to recreate this rhombus so that it's twice as long. So there's 2 blocks, but I can't stop here because I've only increased the width by 2. I've not increased the height by 2. So I'm going to continue to add blocks. And now I can see that I have a rhombus that has been increased in both directions, both horizontally and vertically, by 2. So number 1A, where each side is twice as long, it took us 4 blocks to create that. So for number 1A, you need to write 4. 1B, where each side is 3 times as long. I'm going to add another block to the base. Well, this doesn't look like a rhombus, so I need to continue to add blocks. Still doesn't look like a rhombus because I haven't gone 3 blocks high yet. So I need to continue adding blocks until it looks like the rhombus. Now it looks like the original shape, so it is the same shape, but it's just bigger. So it took us 9 blocks to create that. So 1B, the answer would be 9. And where each side is 4 times as long, I'm going to continue to add blocks. So I have 4 on the bottom, and I need to continue to add blocks until we recreate a rhombus that is 4 times as long. So it took us 16 blocks to create that. So for number 1A, you should have 4. 1B, you would have 9, and 1C, you would have 16. Let's take a look at the green triangle. So for number 2A, where each side is twice as long. So you can see where my base has gotten 2 times as wide, but now I need to continue adding blocks until it is twice as tall as well. So it took us 4 blocks to create that. So number 2A would be 4. 2B, I'm going to make it 3 times as long. So it's 3 times as long on the bottom, but I need to continue adding blocks until it looks like that triangle. And there's the triangle back that we started with. So it took us 9 blocks to create that. And now I want one using a scale factor of 4. So I want the length to be 4 times as long. And I need to continue adding triangles until I get my original triangle shape back. So you can see that it took 16 to create that. So now we're going to look at the trapezoid. On the trapezoid screen, I chose to add the grid box so that you can see when I add these blocks at the bottom, using a scale factor of 2, you can see that it is indeed 2, because you'll notice when I start adding these blocks, they don't lay side by side like they did with the triangle and the rhombus. So you can see down here on the bottom where it is now 2 blocks wide, and we're back to the shape of the original trapezoid, so it took us 4 blocks to build that. So now we're going to do a scale factor of 3. So it was, the original base of the trapezoid was 2 units wide. So if our scale factor is 3, we want it to be 6 units wide. So I'm going to start adding some shapes. And you can see by the time I've added those shapes, the base is now 6 blocks long. 1, 2, 3, 4, 5, 6, which is what we were looking for a scale factor of 3. And we recreated the same shape. It's just bigger. And it took us a total of 9 blocks to do that. And for a scale factor of 4, we're just going to continue adding blocks. So it was originally 2 blocks wide. So if it's a scale factor of 4, then it should be 2 times 4 is 8. 1, 2, 3, 4, 5, 6, 7, 8. It's now 8 along the base, and it took us 16 trapezoids in order to build that. So 3A should say 4, 3B should say 9, and 3C should also say 16. Did I say 3B should be 3? I think I said that wrong. 3B should be 9. So what you're going to do then is we're going to fill in that table at the bottom of your notes. So if the number of figures, let me get a pen here, if the number of, well, maybe, we're trying to figure out how many blocks it would take to build figures A, B, and C. So remember, figure A was that rhombus. If the scale factor was 1, we know we're going to get the exact same thing. So it would only take 1 block to build that, whether I'm talking about the rhombus, whether I'm talking about the triangle, or whether I'm talking about the trapezoid. We figured out up there in the top for number 1A, if the scale factor was 2, to recreate that rhombus, it would take us 4 blocks. To recreate the triangle, it would also take us 4 triangles. And to recreate the trapezoid, it was also 4. When our scale factor was 3, to recreate the triangle, it took 9 blocks. To recreate the triangle, it took 9 blocks. To recreate the trapezoid, it took 9 blocks. So figure A was the rhombus, figure B is the triangle, and figure C is the trapezoid. We also did it where it was 4 sides, or 4 times the original base. So if the scale factor was 4, to recreate the rhombus, it took us 16. To recreate the triangle, it took us 16. And to recreate figure C, which was the trapezoid, it took us 16 pieces to do that. So what I want you to do is kind of think about, do you notice any sort of a pattern that's in this table that's relating the scale factor to the number of blocks that it takes to build it? Hopefully you're noticing that the scale factor, if it's multiplied times itself, that gives you the number of blocks you would need to build that new figure. So 2 times 2 would give us 4. 3 times 3 would give us 9. 4 times 4 would give us 16. So how many blocks would it take if the scale factor was 5? If the scale factor was 5, 5 times 5 is 25. No matter which shape I am trying to build, it's going to take 25 pieces to recreate a scaled copy of that. So if it has 10 sides, 10 times 10 would be, or if the scale factor is 10, sorry, we would have to use 100 blocks to recreate a scaled copy, and 100 triangles to recreate a scaled copy, and 100 trapezoids to create a scaled copy. That would be a really big figure to have to work with. So the thing that we're noticing is that whatever the scale factor is, you square it or multiply it times itself to figure out how many blocks it would take for you to build that. So what if we were just talking about S, the scale factor being S? In other words, I don't really know what it is, but it's some random number. It can be any number that I want it to be. Well, it's going to work the exact same way it works with numbers. We've been taking all of these numbers and multiplying times itself to get the number of pieces needed. So we take S times S, which is the same thing as saying S squared. The scale factor squared is going to tell me how many blocks it takes to create that figure. So if our scale factor was 1/2, and I know that's kind of hard to read on your notes, but that's what it says, 1/2, we would do 1/2 times 1/2, and 1/2 times 1/2 is 1/4. So no matter which shape we would be working with, it would take 1/4 of a block to build that shape. I know that sounds kind of weird, but it would take 1/4 of a block to build that shape. So big key idea here is our when we synthesize at the end of every lesson, it's our big key idea. What did we learn? So our synthesis for this lesson says that when we multiply the base and the height, each by the scale factor, and then multiply the results, we are multiplying the original lengths by the scale factor 2 times. So the effect of this process is the same as multiplying the original area by the scale factor squared. What I have written in the red box down here at the bottom is super important. You either need to put it on the bottom of that note sheet, which I would say that's probably the best place to put it, or you could put it where you wrote your goals, either one. To find the new area of a scaled copy, what you're going to do is you're going to take the original area and you're going to multiply it by the scale factor squared. And that would give us the new scaled area. So when we were talking about how many blocks it took to build each one of those shapes, we're basically talking about the inside of the shape. Okay, that's like talking about the area. So we're going to take the original area, multiply it by the scale factor squared, and that would give us the new squared area. So for example, if I jump back to our online program, one block, one trapezoid would have been the area to start with. We had a scale factor of 4. The scale factor of 4 is 16. So our original area, I can't write on that slide. Our original area was 1. Our scale factor was 4. So if you take your original area times your scale factor squared, it will tell you your new area. So let me jump back onto a slide where I can write. So our original area was 1, because it was one shape, times the scale factor. I said, well, we're building it 4 times as big, and you square that. We get 1 times 4 squared is 16, and 1 times 16 is 16. That's how many blocks it took us to create a scaled copy that was 4 times larger. So if all the dimensions of a scaled copy are twice as long as in the original shape, will the area of the scaled copy be twice as large? That is not true. Because the sides are twice as long. It's twice as long wide, but it's also twice as long tall. So you are supposed to be squaring that. So twice going one direction, right and left, twice going up and down makes it 2 times 2, which would make the actual scaled copy be 4 times the size, or the area would be 4 times the size. So if the scale factor is 5, how many times larger will the scaled copy's area be? Remember, you take your original area and multiply by the scale factor squared. So if the scale factor is 5, 5 times 5 is 25. The scaled copy's area is going to be 25 times larger. So for homework tonight, I want you to go ahead and try that practice problems 1-6. I have posted the answer key now to worksheet 1-5, which is what we did yesterday in class. So take an opportunity to back up on our Canvas, or back up on my agenda and look at yesterday's worksheet 1-5. Check that, grade that. When you come into class tomorrow, we will actually work on looking at the answers to 1-6 together. And then I'll see if anybody has any questions on anything before we take our quiz. Reminder, if there's something in this lesson that you're not understanding, please make sure to ask questions at some point in time, preferably before we take that quiz.